Question number 41. The most commonly used method for triggering of the SCR is option A voltage triggering, option B thermal triggering, option C gate triggering, option D all of the above. So here all the methods are used, all the methods given here, voltage triggering, thermal triggering, gate triggering, are used for the turning on of an SCR or thyristor. What among those, gate triggering is the convenient and most reliable one, because generally voltage triggering and thermal triggering increases the junction temperature and hence it will damage the device in future. So gate triggering is the proper method for turning on or switching of the thyristor. Next question, question number 42. Here is question number 42. The rectifier which requires minimum amount of filtering is a half wave rectifier, voltage doubler circuit, full wave rectifier, none of these. So here full wave rectifier, because please realize this one. Suppose this is the output voltage wave of half wave rectifier, so we can say that it requires more filtering, because we have to find out ideally this type of voltage. Suppose this one is 5 volt, but this is half wave. Here this is sine half cycle and then 0, again sine half cycle, again 0. But in case of full wave rectifier, this is also field off. That is why this wave is more or less more convenient to find this like structure by filtering. So full wave rectifier will require less amount of or minimum amount of filtering. If this wave is more DC, just like this, so this will, in case of three phase or multi-phase rectifiers, it will require more less filtering or less filtering circuit requirement. Next question is, which of the following device does not have gate terminal? So here diac has no gate terminals. Next question is, LASCR is a vacuum device, unilateral device, bilateral device, none of these. LASCR is light activated SCR, that is silicon controlled rectifier. So here this one is this one has the same identical voltage current characteristic like that normal SCR, but it has the activation not due to the gate terminal, but due to the light source. So this is a light activated SCR, and here it is not a bilateral device, because in case of bilateral device, both first quadrant and third quadrant shape of the voltage current characteristic will be identical, but in this case this is not the identical, because in case of third quadrant, breakdown occurs at very high voltage and not conduction is generally not happened in reverse biased condition. So this is unilateral device. Option B is the correct answer, and this is not a vacuum device. Question number 45. A capacitor of 50 microfarad is charged to 50 volt through a resistance of 20 kilo ohm. The time taken in seconds to fully charge the capacitor is. So here what is given, this type of circuit is explained, in which 50 microfarad capacitor is to be charged to 50 volt through a resistor 20 kilo ohm. So we have to charge this capacitor to 50 volt, and we know that this circuit will resemble the first order circuit. If you recall the control system, in control system first order circuit, you know that the time which required for a system to get 63% of the final output is called the time constant, time constant. So here also you will get the similar time constant whose value is RC. We always know from the network theory that RC is the time constant. So what is the time constant here? R value is 50 microfarad and C value is 20 kilo ohm. So RC will be 20 into 10 to the power 3 into 50 into 10 to the power minus 6, which is equal to 1 second, which is the time constant. Next thing is we are getting 63% of output, 63% of final output at time constant, but we have to find out how much time it will take to fully charged. So here from this control system we know that for first order system generally 5 time of the time constant, 5 time of the time constant it takes to reach the final value at 99.3% value, 99.3% of the final value. That is, here I have written tau. If tau is 1 tau, that means we are getting 63% of the output, final output. Suppose final output, this one is the final output, this one is the final output is suppose 1, then 0.63 is tau, 0.63 is tau, 0.7 is 0. If we take this one, this much, this is 0.7 of 0.5 of the final value, that means 50% of final value. And when we are getting at 1 by root 2 of tau, 1 by root 2 of tau, that means half power or the 3 dB value, that is 0.707 tau. Again is 4 tau. At 4 tau we are getting nearly equal to the final value, that is 0.98% of the final value. And at 6 tau, at 5 tau we are getting 99.3% of the final value, that means nearly or equal to the final value. So we can take here that 5 tau, that means time tau is here 5 second and here 5 tau is 5 second. That means option A here is the correct answer. Next question is, a Geno diode has high forward voltage rating, sharp breakdown at low reverse voltage. Option C here given, negative resistance. Option D, none of these. So here a Geno diode has sharp breakdown at reverse voltage, because Geno diode is designed for operation in the breakdown region or in the third quadrant of VI characteristic. Next question is question number 47. A thyristor holding current is option A more than latching current, holding current is more than latching current, holding current is less than latching current, equal to latching current, 0. So here this is very easy thing and already discussed in many videos that holding current is always less than latching current. How to remember this one? H and L. So H, suppose I am thinking it to be high and this to be low, but we have to remember latching current is higher than holding current. Latching current is higher than holding current. So next question number 48. The turn on time of an SCR in series with RL circuit can be reduced by option A, increasing resistance, decreasing resistance, increasing inductance, decreasing inductance. So this is decreasing the inductance value, This is because in any circuit, turn on time of SCR in series RLC circuit, series RL, not C, series RL circuit. Suppose this one is the thyristor and this one is this one is L and this one is R. This one is the circuit, and in this circuit we have to decrease the turn on time of SCR, because due to L current increasing, that is di by dt, current flowing rate decreases, and if we decrease the value of resistance, this value will increase and will help in switching on the thyristor early. Next is question number 49. When UJT is used to trigger an SCR, the wave shape of the voltage obtained from UJT circuit is this is a sawtooth waveform. This is a sawtooth waveform. So here option C is correct. Next question is, which of the following PNPN device has two gates? Triac, SCS, SUS and dias. This is not dias, this is diac. C. This one is C. So here if we see the SCS, that is silicon controlled switch. Silicon controlled switch has two gates. SUS, what is SUS? SUS is silicon unilateral switch. So here in this question answer is silicon controlled switch, and its notation is like this. Here are two gates. One is anode gate and another is cathode gate. And how it is turned on? When we apply anode positive, cathode negative, that means forward biased condition. In case of forward biased condition, or anode is connected to positive terminal, cathode is connected to negative terminal. If we provide the cathode gate with positive supply, with positive value with respect to cathode, then it gets turned on just like SCR. But in case of anode gate, we have to provide negative supply, negative potential of voltage, so that it turns on. So this is the difference between SCS and thyristor. Only this one is the difference. Next is question number 51. In class E external pulse commutation method, the external pulse is obtained by, this is battery. External pulse is always obtained by external source. In books you will find that external source, and here these are not sources. So external source is battery, and this is a commutation. We are talking about commutation, and this is generally connected to a AC or anything which at AC or DC for inverting or rectification of application. But for this commutation purpose, generally external pulse is required, that from battery or external source. Next question is, for discontinuous load current and excitation angle beta greater than pi in a single phase full converter, each thyristor conducts for beta minus alpha. That means here is the, suppose this one is the source voltage, and what is beta is generally, alpha is generally here the firing angle, and what is beta is the extinction angle. Here is the beta, and for how long it flows current to this much period, and that means beta minus alpha, the thyristor conducts. And from pi to beta, how this conducts? This conducts only due to the inductance of the load, or the flyback diode, or the feedback diode. Next question is, in a single phase full converter, the number of SCRs conducting during overlap is, this is 4 number of SCRs or thyristors conduct during overlap in case of single phase full converter. Next question is, in circulating current type of dual converter, the nature of voltage across a reactor is alternating. This is alternating. Nature of voltage across reactor. Reactor means in case of current dual converter, here is a converter and here is a converter, here is the load and here are the two inductors, and here the two inductance. Here is the voltage across inductor or the reactor, VL, and this VL is alternating. Next question is question number 55. In a three-phase semiconverter, frequency of ripple in the output voltage. In a three-phase semiconverter, frequency of the ripple in the output voltage may be. So in case of three-phase semiconverter, frequency of ripple in the output voltage is 3 times the supply frequency for firing angle greater than 60 degree. when firing angle alpha is greater than 60 degree, it acts as 3 poles semiconverter, 3 poles converter, 3 poles converter. And in case of alpha smaller than 60 degree, it acts as 6 poles converter. And here in this question both option B and C are correct, because in case of semiconverter, 3-phase semiconverter, the frequency is 3 times the supply frequency. The ripple frequency in the output voltage is 3 times the supply frequency for firing angle greater than 60 degree, and 6 times the supply frequency for firing angle less than 60 degree. So here both option B and C are correct. Next question is question number 56. The output voltage expression for single phase semiconverter is. So this one is the output voltage expression, that is Vm by pi into 1 plus cos alpha. Alpha is the firing angle, Vm is the maximum voltage. Which of the following chopper circuit is preferred for motoring operation of DC motor load? So here options are given. Option A, first quadrant chopper, second quadrant chopper, third quadrant chopper, fourth quadrant chopper. And in generally third quadrant and fourth quadrant are not used independently. That means there are no chopper which are operating in third quadrant and fourth quadrant. Generally there are the choppers which are named like type A, type B, type C and type D, type E. And what are the other choppers? Type A operates in first quadrant, type B operates in second quadrant, type C operates in both first quadrant and second quadrant, type D operates in first and fourth quadrant, and type E is 4 quadrant chopper. That means it operates in 4 quadrant, in all the quadrants. So here what is the question? Question is for DC motor load, what type of chopper is generally used. So here we will see that what type of chopper we can use. In case of first quadrant, both voltage and current are positive. That means voltage and current positive means power is always flowing from source to load. That means from this one is suppose motor and this one is load. This one is motor and the load, and this one is the source. And power is always from source to load in case of first quadrant or type A chopper. This is motoring action. But in case of quadrant 2, the power flow is from motor to load. That means from load to source, load to source. So in case of regenerative braking, we have already studied what is regenerative braking in DC motor braking. And in case of regenerative braking, when there is the inertia of moving of that load, and we we will disconnect the DC motor from the supply source, what it will does, it will generate voltage. That means back EMF will be higher than that of the source voltage, and in that condition load provides voltage to the source. So in case of second quadrant chopper, we can say that this is regenerative quadrant. That means power flow is from load to source. That is why here voltage is negative but current is positive. In case of third quadrant is motoring, and this one is reverse regenerative. So here we can see generally the choppers are used type C choppers, which are used for DC motor loading, which can both act as motoring and regenerative braking. And this one is reverse motoring. That means terminal voltage will be changed. And it may cause what is that? That is the direction of the revolution depending upon what type of motor it is. So we are not discussing that one, but here generally for DC motor load, first and second quadrant operation are needed, and generally type C type C chopper are used, but in these options there is no type C chopper, there are only quadrants are given. And if we select option B, only regenerative braking is possible, not motor load is possible, motor loading is not possible. So here this is not correct. Option C is also not correct. This is the reverse, this is the reverse motoring condition, and fourth one is reverse regenerative condition. So here option A is the only chance we can select here. If given that type C also, then type C will be selected over type A for DC motor load operation. Next question is 58. In single thyristor chopper circuit, the capacitor discharging current is oscillating but decaying in nature. Option B, pulsating, alternating, none of these. So here in case of thyristor chopper circuit, capacitor discharging current. So here this is one of the chopper, and in which here is the capacitor, and when this circuit, this switch is closed, this capacitor will be charged, exponentially to that voltage, to that V source voltage. V source is the DC volt. And when this is opened, this switch is opened, what will happen? This will discharge through load, and again when switch is closed, it will charge to that voltage, and again it will discharge. So we can see that this is pulsating in nature, not alternating or oscillating but decaying, because oscillating but decaying means this like wave, oscillating but decaying, that means magnitude or the amplitude will decay gradually. Next one is alternating means polarity must be changed from one to another. So this is alternating. Next question is, when a series LC circuit is connected to a DC source of E volt through an SCR, then the peak current through SCR is. So what is given here? Single LC circuit, that is there is no R. So we can compare this to the surge impedance. Of a transmission line where there is no R, that means lossless transmission line. This is not the practical case, but we can compare and solve this question here. So here, what will be the surge impedance of the line or the characteristic impedance when there is no R? This will be root over of LC. And what will be the current? Current will be only the charging current. Sorry, not the charging current. This is the current when there is no R. Charging current is due to the capacitance only. So here, what will be the current? V by root over of L by C. So this will be V into root over of C by L. Option C here is the correct answer. Next question, if two or more choppers are operated in parallel and shifted from each other, the ripple frequency will be. So here what is given? If two or more choppers are connected in parallel and shifted from each other, this should be given that this is actually saying about the multi-phase choppers. That means two or more choppers are connected in parallel to operate, so that it can provide higher current than a single one. So then next is given that shifted from each other. See, this is actually not shifted from each other, this is phase shifted from each other. The frequency will be how the ripple frequency of the output is affected by the phase shifting. So multi-phase, why generally we use multi-phase chopper? Where we require high current output, and by the using of a multi-phase chopper, ripple amplitude is generally decreases and ripple frequency increases. So here answer will be increases. Answer is option C. But we will see how it happens. So here are the explanations. In case of multi-phase chopper, so here one chopper output is this one, output this one, and another is this one, and both are connected in series, and the phase is not shifted. That means they are in phase. in phase, they are in phase. So what will happen, they are in phase, so what will happen, all the choppers and on and off at same instant, that means they are synchronized, they are synchronized. So what will happen, this amplitude suppose I and this amplitude suppose I, this will be added off and finally we will get 2i here, 2i here, but the frequency is not affected, only amplitude of the wave is affected here in case of in phase. But in case of phase shifted one, suppose this one is the first chopper having amplitude I, and here in second one also amplitude I when they are, but second one is phase shifted, that means this one is phase shifted by some angle, and this will be added off to give like this, give like this. Here also amplitude highest magnitude is also the same, that is I. Here the amplitude is not increased, but the frequency or the ripple frequency increased, because here the frequency is this one, here frequency this one, and here is frequency is doubled if they are phase shifted like this, if the phase shifted like this. So here in this case different choppers on and off at a different instant. So here option is increase. Next question is, a single phase AC voltage regulator fed from 200 volt 50 Hz source is connected to a RL load. If R is 2 ohm and L is 6.36 millihenry, what will be the control range of firing angle for the SCRs? So for this type of circuit, that is a single phase AC voltage regulator, generally the minimum value of firing angle is defined as phi, which is equal to tan inverse of omega L by R, tan inverse of XL by R, and omega here is 2 pi f is given to be 50 Hz into L is given to be 6.36 millihenry by R is 2 ohm, and what will be the result will be 45 degree angle. This is the minimum value of firing angle, and what will be the maximum possible firing angle, which is always 180. So here answer is option C, that is from 45 degree to 80 degree. Option C here is the correct answer. Next question is, a single phase voltage controller feeds power to a resistance of 10 ohm. The source voltage is 200 volt for a firing angle of 90 degree. The RMS value of thyristor current is. So single phase voltage controller, so for single phase voltage controller, the thyristor current is given like that, thyristor voltage is given like this. This one is the thyristor voltage across the thyristor, and this one is the RMS value. What is the formula? Vm by 2 root pi r into pi minus alpha plus half sine 2 alpha to the power half. And if we put the values here given 200 volt, this one is the rating given, and this one is always in RMS value. So here we have to put Vm, that is maximum value, and this one is sinusoidal, so root 2 into the RMS value, So if we put this one, this will give the RMS value to be this much, RMS value of this much will be this, and what is given here, this one is the, and feed for the resistance of 10 ohm. For 10 ohm, this one will be 2 into 10 here. Sorry, this one is actually the RMS current. I have explained wrong. This one is RMS current because R is present here. If we eliminate that R, it will be only VRMS output. So here answer is 10 ampere. Next question is, a cyclo converter has option A high input power factor, option B low input power factor, option C unity power factor, option D zero input power factor. So a cyclo converter has low input power factor. Next question is, the number of SCRs required for single phase to single phase cyclo converter of midpoint type and for 3-phase to 3-phase 3-pulse type cyclo converter are respectively. So what are the cyclo converters given? One is single phase to single phase cycloconverter of midpoint type. This is one type, and another type is 3 phase to 3 phase 3 poles type. So for first one we will require 4 thyristors, and for second one, that is 3 phase to 3 phase 3 poles cycloconverter, we will require 18, and for 3 phase to 3 phase 6 poles type cycloconverter we require 36. So here answer is option C. Next question is question number 65. The output frequency of a cycloconverter is significantly lower than the input frequency for option A, keeping commutation failure, B, avoiding commutation failure, option C, reducing switching losses, option D, none of these. So in this question what is given, output frequency of a cycloconverter is significantly lower than that of input frequency. So what is the work of a cycloconverter? It converts one frequency to another frequency in case of AC voltage source. So in the cycloconverter in which output frequency is lower than that of input frequency, this is called step down cycloconverter. And in this step down cycloconverter, no post commutation or commutation circuit is used for SCRs. So we can say that this one is line commutated or normally commutated. But in case of step up cycloconverters, that is cycloconverter in which the output frequency is higher than that of input frequency, at that condition post commutation is required. But in this case output frequency is lower than that of the input frequency. So we can say that this one is a step down cycloconverter, and line commutation is needed. So which option will be true or the correct? Option A is given, keeping commutation failure, avoiding commutation failure. That means avoiding commutation failure means we are using some circuit to avoid commutation failure. We are forcing the commutation, we are making the commutation compulsory. So this is not the case. This means we are using the post commutation, keeping the commutation failure. That means this one is line commutation, and option A will be correct answer. Reducing switch losses, this is not accurate for this question also. Next question is, a single phase current source inverter is connected to a pure capacitive load. For a constant current source, the voltage across capacitor is. So this is a simple thing. What is given here? Single phase current source inverter is connected to a pure capacitive load for a constant current source. That means here current is constant, the voltage across the capacitor is. So forget about what is given, only consider this much. For a constant current source, the voltage across the capacitor is. And first sentence you forgot. So from this second sentence, what we are getting? Constant current. That means current is constant. For step function, constant means step function. So what will be the value of voltage across the capacitor? What will be voltage? For triangular shape or a ramp shape of voltage, derivative of voltage will be derivative of voltage or a derivative of a triangular wave will be step. Suppose voltage is like this, so that current will be like this, or the voltage is like triangular shape, that means like this, then voltage will be like this, so these are not connected, so the voltage will be like this. So here we can say that voltage is triangular, or the integration of unit step or the step function is the triangular one. V is equal to 1 by C integration of I dt. Next is, a DC chopper is shown in the figure. If the duty cycle of the switch is D, determine the power absorbed by the switch, assuming switch to be ideal. So here also forget everything and only consider this one. Assume the switch is to be ideal. For ideal switch, what should be the power absorbed by that switch? Power absorbed should be 0. So here Answer will be 0. Answer will be 0. If the switch is not ideal, then it will absorb some power. Next is question number 68. A Schottky diode is a option A majority carrier device, option B minority carrier device, option C fast recovery diode, option D both majority and minority carrier diode. So Schottky diode is not a p-n junction diode. This is a n-type semiconductor and metal junction. Generally metal used is aluminum, and n-type silicon, due to the n-type silicon, here the carrier is the electron only. So we can say that this is a majority carrier device only, not minority carrier, and here option A is correct answer. And it has no recovery or recombination time, so it is also a fast recovery diode, but it does not come under the fast recovery diode, because generally under fast recovery diode we are considering the p-n junction diodes, so which are having no recombination time. So we are considering this for the majority carrier device, and this is also faster than conventional p-n junction diode also. What is the shape of inductor current waveform in a boost converter? In a boost converter, the inductor current waveform is the triangular wave, because here we can say that V is equal to L di by dt, current conductor, and here I is equal to 1 by L integration of V dt, and V, due to the switching, V is just like this one, square waves or the rectangular waves. So what will be its integration? Voltage is like this. That means if we integrate this one, this will be like this. That means suppose this one is 5 volt, this one will be 5t. That means ramp signal or the triangular. Next one is the major function of a pulse transformer is option A create periodic pulse, option B increase the voltage amplitude, option C reduced harmonic, option D isolate low and high power circuit. So the major function of a pulse transformer is used for providing pulse to the gate circuit of an SCR. So what is the major function of a pulse transformer? Here, to isolate high power circuit and low power circuit. The main anode line or anode circuit is generally the high power circuit, and gate triggering circuit is the low power circuit. And if we provide the gate triggering from, we will draw power from the anode cathode circuit and we will provide that one. That means we are considering the same circuit. If we provide it through a pulse transformer, that means we are isolating low power and high power circuits. Here also given options create periodic pulse. It does not create periodic pulse. It only provides it only isolates or manipulate that pulse. Pulse is provided by PWM generator. Next is increase the voltage magnitude. This may be true, option B may be true, but in generally ratio of pulse transformers are 2:1 or 1:1. That means step down or 1:1. That means equal value. Primary and secondary has equal value. So increase in voltage amplitude is also wrong. And next is reduce harmonics. This is purely wrong. So here option D is the correct answer. Next question is a single phase half bridge inverter has load R is equal to 2 ohm and a DC voltage source Vs by 2 is equal to 115 volt. Find the RMS value of the fundamental load current. RMS value of fundamental load current. So what is the RMS voltage value? RMS voltage value V01 is equal to 2 Vs by pi sin omega t. So here Vm is equal to 2 Vs by pi. What is Vrms? Vrms value is 2 Vs by pi by root 2. So here what will be IRMS? This value by the resistance, that is 2. So VRMS is equal to 100. If we calculate this one, this will be 103.53 and IRMS will be 51.7 ampere. And here Vs here Vs by 2 is given to be 115, and we have to put here 2 Vs, and Vs will be 2 into Vs by 2, that is 230. So I have put here 230. Next question, question number 72. In an ideal boost converter, if switch is always kept off, what will be the output voltage? So in ideal boost converter, switch is kept always off. Switch is kept always off. So here is the boost converter. Here is the boost converter. What will be the output voltage? Output voltage will be equal to the input voltage. Switch is always kept open or off. What will happen? This voltage will be appeared at this, because due to DC voltage source, this will act as short circuited, and this will act as open circuited after fully charged, and this will be forward biased. So the total input voltage will be appeared at the output. So V output or V naught will be equal to V in. Next question is what is effective input resistance of a DC to DC buck converter connected to a load reference R? Assume duty cycle to be D. So here given that output load resistance is R, and we have to find out input resistance of DC to DC buck converter. So here DC to DC buck converter is given, and if we consider the efficiency of that converter to be nu, so what will be the output power, that is the V output into I output is equal to efficiency into V input into I input, and we know that I naught is equal to V naught by Z naught, and Z naught here is the output impedance, and Zi here is the input impedance. This one is the efficiency, and Vi square by Zi. So from this we can say that we know already for buck converter V output is equal to D into Vi, where D is equal to duty cycle. So here we can write a dVi whole square by Z naught is equal to epsilon, not epsilon, this one is nu into Vi square by Zi. Only I have put here in place of V naught I have put dVi in that expression. So what we will get? Vi square get cancelled, and what we will get? D square by Z naught is equal to nu by Zi. So Zi is equal to efficiency into Z naught by D square. So for epsilon, not efficiency to be 1, that means 100%, or Z output, that is output impedance, to be R, as given here. Zi will be here R by D square. Option C here is the correct answer. Next question is question number 74. A dual converter is used in DC motor drives to obtain regenerative braking. Option B, reversible speed control. Option C, plugging. All of these. So here all of these, because we are using dual converter for all these purposes. Next question is, in multi-pulse modulation of inverters, the square wave and triangular waveforms are respectively used as carrier, reference carrier, none of these. So here I have put the image here. This one is already written here. Carrier signal is the triangular wave, and reference wave is the square wave. So here square wave is the reference wave, and triangular wave is the carrier waveform. Next question is question number 76. Why resistor is used in snubber circuit? Option A, to minimize loss, to minimize charging current, to minimize the discharging current, all of the above. So here to minimize the discharging current, discharging current. Next question is, a three-phase fully controlled converter is feeding power into a DC load at constant current of 150 ampere. The RMS current through each SCR of converter is. So current through thyristor is equal to I naught by root 3 in case of three-phase fully controlled converter. Three-phase fully controlled converter, I naught by root 3, which is equal to 150 by root 3. So here answer will be 150 by root 3. And if in this question asked for the source current, this has asked the current through SCR, but it has asked if it has asked for the source current will be I naught into root 3, sorry, root over of 2 by 3, root over of 2 by 3. Next question is question number 78. For controlling the speed of three-phase induction motor, which method is normally adopted? Constant voltage, constant frequency, constant voltage, variable frequency, variable voltage, variable frequency, variable voltage, constant frequency. So here we know that in electrical machine, induction motor can be controlled from both its starter portion and from its rotor portion. That means from starter portion we can change both the supply voltage and also the frequency, because if frequency changes, ns, that is the synchronous speed, will change, and also the induction motor running speed will also change. And if we change the voltage by there are different methods to changing the voltage, also we can change the speed. So here both variable voltage and variable speed are considered. Question number 79. A commercial power supply has voltage regulation of generally 1%. Question number 80. In a DC to DC buck boost converter, if input voltage is 10 volt and output voltage is 40 volt, then what is the duty cycle? So here buck boost converters, then what will be the formula? Formula will be alpha by 1 minus alpha is equal to 40 by 10. So what will be alpha value? Alpha into 10 is equal to 40 into 1 minus alpha, and if you cancel out 10 from both sides, it will be alpha is equal to 4 minus 4 alpha, and here 5 alpha is equal to 4 and alpha is equal to 4 by 5, which is equal to 0.8.